Here is the scenario of a two sample t-test, but here variance of both populations are identical. So if the population of if variance of one population is two times greater or more greater than the other population, then we cannot assume this assumption. So let's say if the variance of one population is 10 and second one is 15, so that's fine. But if variance of one population is, let's say, 10 and the second one is 100, then we cannot assume this equal variance, or we cannot say that the variance of both populations are identical. Okay, and here the T naught formula is y1 bar, which is mean of population 1 or sample from population 1, y bar 2 sample of population 2, and they are independent populations, right? N1 is the sample size for sample size of sample 1 drawn from population 1, and N2 is sample size of sample 2, which was drawn from population 2s. P square is the estimate of common variance, and it is very much possible that um, the sample size for both population is not the same. So maybe n1 is not equal to n2, so it's kind of like the balance point, or it's also called the pooled or combined of or a weighted average of the sample variances. Okay, so if after computing this T naught here, and for S P square I have another formula, n minus 1, and then S1 square plus n2 minus n1 in bracket S2 square divided by n1 plus n2 minus 2. So this is degrees of freedom here also, n1 plus n2 minus 2. Okay, and here we would like to test the mean, whether the mean of two populations are same or not. So once I have this test statistic value T naught, if this is greater than T alpha by 2 n plus 1 plus n2 minus 2, right? If it is in that region, so we will reject uh, null hypothesis, and if it is in that whitish region, so it's, we will say okay, fail to reject, because these are our cutoff values for rejection region. And because we were performing two-tail test, not equal to 1, my alternative hypothesis is not equal to, right? So we will check both sides, greater than and less than. So I will divide alpha by 2 here. So here I have two let's say mortars. One is modified, second one is unmodified, and I want to know that whether both will give me the same strengths or not. Y1 bar, which is the mean value, is given, standard deviation is square, so variance and standard deviation are given, and sample size given also here. So if you can see, sample size for both the samples are the same, and they are two different populations. Y2 is Y2 bar is the average value, average strength value for unmodified motor. S2 square is the variance, and S2 is the standard deviation. Null hypothesis is mu naught is equal to mu2, that both have similar strengths, average value of strengths for both motors are equal. um, each one alternative hypothesis that mu1 is not equal to mu2. So here not equal to could be greater than and less than. So here I have to divide alpha by 2. Okay, alpha is given, which is 5%. Degrees of freedom is n1 plus n2 minus 2, which comes out to be 18. With the help of formula you can calculate the value of SP here. Second step would be to calculate the test statistic value here, T naught. Y1 bar is known, Y2 bar known, and one value and2 SP value we just computed. So this value comes out to be minus 2.2, right? This is my test statistic value, and this value is telling me that how far I am from the mean value. Now let's go to that cutoff region. Cutoff region formula is here. Here. T alpha by 2, because it was two tail test, so we are dividing alpha by 2. N1 plus n2 minus 2, so that's 18. Okay, let's go to table and calculate that value, or find that value. Alright, so 0.025 for alpha and 18 is my degrees of freedom, so 2.10, right? So my cutoff here is 2.10 and minus 2.10, right? My value here is minus 2.20, which is smaller than this lower value of 2. So I'm in that rejection region. So here I can say that okay, we would reject at notch, and we conclude that the mean tension bond strengths of two formulations of Portland-Simon motor are different. This means that we cannot say that okay, both methods are giving us the same strengths. Why? Why? Because you see this line, this is my minus 2.1, which is my cutoff region, but my value, which is the test statistic value, is here, minus 2.20. So it's in that rejection region. That is the logic that we are rejecting our null hypothesis. So you can just use, instead of computing the T naught value and SP value, you can just directly um, perform two sample T tests for any problem using Minitab. And here are the steps. So the important one is that you have to check assume equal variance option. Here, the as I mentioned before, that the software will give you p value directly. So p value here is 0.042, which is very small compared to my 5%. So that is why we reject our null hypothesis. Here are few assumptions for t-test. Before you are performing, it's a good idea to check that both samples are random samples that are drawn from independent populations that can be described by normal distribution. So it's a very good idea to check the normality using the um, probability plots, and you can easily do it in Minitab. The equal variance and normality assumption are easy to check using a normal probability plot. In Minitab it's very easy. Okay, so this is the scenario in where variances of two population are not equal. in our previous scenario we assume that variances are equal. In this particular scenario variances are not equal, so the T-naught formula changes a little, and the degrees of freedom formula, it also changes. Before it was n1 plus n2 minus 2, but for this particular scenario we are using a different formula. So here we have data, and we would like to calculate if both mean values are the same. Here h1, which is this thing is important to know, that here h1 is greater than mu, mu1 is greater than mu2. So because we are not saying not equal to, we are only saying greater, so I don't need to divide this alpha by 2. So alpha, whatever the alpha value is given in the question, it will be my alpha. I won't be dividing. If it was, let's say, less than, I still don't need to divide alpha by 2. But if it was not equal to, right, the h1, then I will divide alpha by 2. So sample size is given, mean value, standard deviations, and so everything is given. I can easily compute the value of T naught, which comes out to be 2.7354. I calculate degrees of freedom, which comes out to be 16.19, so almost 16. I can calculate the cutoff value for um, for T, which is alpha is 5%, and then degrees of freedom we can take this as 6. So was it 16, right? 16 here and 5%, so it's 1.746. That is my cutoff region. T naught value, which is 2.7354, is greater than my cutoff region 1.746. So that is why we are rejecting null hypothesis, and we conclude that two means are not equal, and there is significant differences between the mean values of two populations. And here I can also the p-value is very small, so um, it's very small compared to this 5% value, so I can also make my decision on the basis of p-value if I'm using a software result. Okay.